But it's actually worth noting that Grok 4, if given like the SAT, would get perfect SATs every time, even if it's never seen the questions before.
For more than 70 years, scientists have been stuck on one unsettling question. If the universe is this huge, this old, and packed with worlds that could support life, where is everybody else? Recently, researchers turned to Grok, the advanced artificial intelligence developed by xAI, for answers. What came back did not sound like the alien contact stories people expect. It also pointed to a far darker possibility. What if every intelligent civilization reaches a breaking point it cannot survive, and humanity is already moving toward the same point of no return? Where is everybody? Grok became part of this debate because it can pull together huge amounts of human knowledge. The question Grok was asked has haunted science since one lunch in the summer of 1950. Enrico Fermi was eating with other scientists at Los Alamos when the talk turned to flying saucers and life beyond Earth. Then Fermi cut through the discussion with a question so simple that it never went away. Where is everybody? That question became the heart of what people now call the Fermi paradox. A paradox is when two things seem true, but they do not seem to fit together. In this case, the first thing is that the universe should be full of chances for life. The second thing is that we still have no confirmed contact from anyone beyond Earth. The universe is about 13.8 billion years old. Earth is far younger. Our solar system formed about 4.6 billion years ago. That means there were stars and planets long before our planet existed. There may have been worlds with oceans before Earth had land. There may have been planets where life had time to rise, change, build tools, and disappear before the first humans ever looked up at the night sky. That is what makes the silence so hard to ignore. We are asking this question in a universe that has had a massive head start. Our galaxy alone is enormous. The Gaia space mission watched the sky from July 2014 to January 2025 and made more than 3 trillion observations of about 2 billion stars and other objects. That did not even cover everything in the Milky Way. Then came the planets. By early June 2026, astronomers had confirmed more than 6,200 planets outside our solar system. Some are giant worlds hotter than fire. Some are dead and frozen. Some race around their stars in days. Others sit in places where liquid water might be possible. That last part is what changed the whole conversation. Water does not prove life, but on Earth, life needs it. So when astronomers find planets in the right temperature zone, they pay attention. In 2020, researchers estimated that the Milky Way could hold as many as 300 million potentially habitable worlds. Even if that number is too high, the point remains hard to escape. The galaxy is not short on planets. It is not short on old stars. It is not short on time. If life can begin in many places, and if intelligence can rise in some of those places, then Earth should not be the only world that reached this stage. Yet there is no confirmed alien message, no verified signal, no clear sign of another advanced civilization waving back. That is why the question refuses to die. Maybe life is rare. Maybe intelligent life is even rarer. Maybe civilizations destroy themselves before they spread. Maybe they stop sending loud signals after only a short time. Or maybe the most advanced minds in the galaxy do not contact young planets the way young planets expect. That is the doorway Grok opened. But before the silence can mean anything, there is one brutal truth to face. Humanity has barely checked the cosmic room it still keeps calling empty. We've barely started looking. The first serious search for alien intelligence started with one radio telescope in West Virginia, aimed at 2 nearby stars. In 1960, Frank Drake used an 85-foot telescope at Green Bank to listen to Tau Ceti and Epsilon Eridani. Both stars were close by cosmic standards. Drake was listening for a narrow radio tone that did not sound natural, something that could suggest technology on another world. Nothing confirmed came back. But that first search changed everything. It turned the question of aliens into something scientists could actually test by pointing instruments at the sky. A year later, Drake wrote an equation that became one of the most famous ideas in the search. It gave scientists a way to think through the problem. How many stars are born? How many have planets? How many planets could support life? How often does life become intelligent? How long does a civilization keep sending signals before it goes quiet? That last question still feels dangerous. Even if a civilization exists, we may miss it if we are not listening at the right time. Space is not just huge. It is also old, dark, noisy, and hard to search. Looking for alien intelligence is not like turning on a radio and waiting for a station to play. It is more like standing beside every ocean on Earth with one cup, scooping a little water, and then trying to decide whether fish exist. Even the biggest searches are still tiny against the true size of the problem. Breakthrough Listen was launched as the most ambitious search of its kind. It was backed with $100 million and designed to scan 1 million nearby stars, the center of the Milky Way, the plane of the galaxy, and 100 nearby galaxies. Its main tools include Green Bank, Murayang in Australia, and an optical telescope in California. But compared with the full search, it is still barely a beginning. A signal could come from the wrong part of the sky. It could arrive when our telescope is pointed somewhere else. It could be too weak. It could be too short. It could use a frequency we are not checking. It could repeat once every 100 years. And even when something strange appears, the job gets harder. In August 1977, a radio telescope in Ohio picked up a strong signal that lasted about 72 seconds. It came from the direction of Sagittarius and looked unusual enough that the scientist reviewing the printout wrote, "Wow," beside it. That signal became famous because it looked exactly like what people hoped an alien message would look like: sudden, strong, and hard to explain. But it never repeated. No one has confirmed where it came from. It remains one of the most famous mysteries in the search. Decades later, another strange signal caused a stir. While studying Proxima Centauri, the closest star system to the Sun, researchers found a narrow signal near 982 megahertz. It looked interesting because Proxima Centauri has at least one planet in the region where temperatures could allow liquid water. Then came the slow, careful work. The signal was traced back to human-made interference. It was not aliens. It was Earth, confusing its own search. That has become one of the hardest parts of listening for life beyond this planet. Earth is loud. Satellites, phones, aircraft, radar, towers, and electronics all throw signals into the environment. Some are obvious, some are messy, some can fool even serious searches until they are studied closely. Every strange signal has to survive a brutal test. Did it come from space or from our own machines? Did it repeat? Did another telescope see it? Did it move the way a distant signal should move? Did it stay fixed in the sky, or did it point back to Earth? Most signals fail. That does not make the search pointless. It shows how careful the search has to be. And even if we built the perfect listening machine tomorrow, there is a deeper problem. The thing we are waiting for may not sound like a message at all. Maybe we're looking for the wrong thing. Humanity has spent decades waiting for a clear message from space. A clean radio tone, a beam of light, a pattern so strange and exact that no one could mistake it for nature. But another civilization may never send that kind of message at all. That is where the search starts to change. Scientists are no longer only asking whether someone is talking. They are also asking whether someone has left a trace. That trace is called a technosignature. It means any sign that technology exists somewhere beyond Earth. It does not have to be a voice. It does not have to say hello. It does not even have to be aimed at us. It could be a radio signal. It could be a laser flash. It could be a strange chemical in a planet's air. It could be heat from a civilization using huge amounts of energy. It could even be a large structure blocking part of a star's light. Earth itself proves how strange this can get. Our planet is full of technology, but that does not mean we are easy to detect from far away. Phones, towers, satellites, radar systems, deep space antennas, and power grids make Earth look busy from up close. But from another star, most of it may fade into almost nothing. A study of Earth's mobile tower signals found that even a telescope as powerful as Green Bank would not easily detect that leakage from within 10 light-years. That is a shock, because 10 light-years is tiny on the scale of the galaxy. If our own modern signals fade that quickly, then another civilization could be active nearby and still remain almost invisible to us. Earth's loudest signs are not always the ones people expect. Ordinary phone signals are weak in space. Old television and radio broadcasts spread outward, but they were never built to cross the galaxy. Fiber cables carry huge amounts of information under oceans without spilling it into the sky. Satellite signals are often aimed where they need to go, not blasted everywhere. So if an alien world followed a path like ours, there may have been only a short time when it was easy to hear by accident. If they are older than us, they may have moved past that stage long ago. This is why technosignatures matter. This is also why the James Webb Space Telescope changed the mood around distant planets. Webb is not listening for alien voices. It is reading light. When a planet passes in front of its star, a tiny part of the starlight filters through the planet's air. Hidden in that light are clues about what the air is made of. It is like reading a fingerprint from hundreds of light years away. In 2022, Webb found clear carbon dioxide in the atmosphere of WASP-39b, a giant planet about 700 light-years from Earth. Then Webb studied K2-18b, a planet about 8.6 times as massive as Earth. It found methane and carbon dioxide in its atmosphere, and scientists discussed whether the planet could have a hydrogen-rich sky and a deep ocean below. That does not prove life. It does not prove technology, but it shows how far the search has moved. We are not just counting planets anymore. We are starting to read them. The next question is even stranger. What if contact is not something advanced civilizations want at all? What if aliens don't want contact? We keep asking why aliens have not contacted us, but that question carries a hidden assumption. It assumes they would want a conversation. That sounds normal to us because humans think in human ways. We meet, we speak, we trade messages, we send greetings. We expect any intelligent life beyond Earth to do something similar if it ever notices us. But that may be the wrong starting point. A civilization far older than ours may not see contact the way we do. It may not think of Earth as a neighbor waiting for a handshake. It may not see humans as equal partners in a great cosmic conversation. It may simply see a young planet with life, tools, noise, conflict, and a fast-changing species still trying to understand where it is. That gap is hard to grasp because human technology is still very young. Our first radio broadcasts are barely over a century old. Our first steps on the moon happened in 1969. Now place humanity beside a civilization 1 million years older. That would not just mean better rockets. It could mean a completely different kind of mind, a different way of storing knowledge, a different way of watching space, a different way of thinking about life, risk, time, and communication. That is why direct contact may not be the obvious next step. When humans study life on Earth, we do not always try to talk to it. A scientist watching bacteria under a microscope does not expect a conversation. A researcher tracking whales may listen carefully, but the whales are not invited into a meeting. A biologist studying a forest does not ask the trees for permission before measuring how the system works. That does not always mean cruelty. It means the gap is too large. If another civilization were far ahead of us, Earth might look less like a nation and more like a living system. They could study our air, oceans, cities, satellites, radio leaks, wars, energy use, and the sudden rise of machines without ever needing to speak. From that point of view, contact is not the first move. Observation is. This idea has appeared in serious thinking about the Fermi paradox. One version is called the zoo hypothesis. The basic idea is simple. Maybe advanced civilizations know about younger worlds but avoid contact so those worlds can develop on their own. Under that idea, Earth is left alone because someone or something has decided not to interfere. But that idea also has a major problem. It would require a level of agreement that is hard to believe. If many advanced civilizations existed across the galaxy, they would all have to follow the same rule. They would all have to avoid contact. They would all have to stay quiet for a very long time. That is why the zoo hypothesis is not an answer. It is a possibility. There is also a darker explanation. Maybe the reason we have not heard from older civilizations is that most never last long enough to become old. This idea is often called the Great Filter. It means that somewhere between lifeless planets and a long-lasting space civilization, there may be a step that is extremely hard to pass. Maybe the hard step is the beginning of life. Maybe it is the rise of intelligent life. Maybe it is surviving dangerous technology. That possibility hits close to home because Earth is already standing near that line. We have nuclear weapons. We have changed the planet's atmosphere. We are building machines that can make decisions faster than humans can follow. We are powerful enough to affect our own future, but not yet stable enough to prove we can survive it. And if older intelligence normally stays silent, then what could Earth do that would finally make us impossible to ignore? What could make Earth stand out? When Grok was asked why aliens have not contacted us, the most unsettling answer was not that Earth is too small to matter, it was that Earth may only become hard to ignore when it becomes dangerous. A young world may become noticeable when its own technology starts changing the planet faster than its people can control. For most of Earth's history, our planet would have looked alive but quiet. Oceans, clouds, forests, storms, fires, volcanoes, and a thin layer of life spread across the surface. Then, in a very short time, one species began to change the signal. We built cities bright enough to shine at night. We filled the air with the marks of industry. We split the atom. We launched machines beyond the atmosphere. We built antennas that could talk to spacecraft across billions of miles. Then we began building machines that could write, reason, learn patterns, and make decisions in ways that belonged only to living minds. Maybe Earth's loudest signal is not ordinary radio. Maybe it is the sudden jump from a living planet to a technological planet. This does not mean aliens are watching Earth. It does not mean anyone is coming. But it does change the question. Instead of asking why no one has said hello, the colder question is what a young civilization could do that would make it worth attention. For the first time in Earth's history, one species gained the power to destroy its own cities in minutes. That kind of power shows why intelligence can become dangerous quickly. A civilization may rise high enough to build powerful tools, then fail because it cannot control them. Artificial intelligence is not just another tool like a telescope or a rocket. A telescope helps us see. A rocket helps us move. Artificial intelligence can help us think. It can search, write, design, test, copy, improve, and connect ideas no single human can match. That makes it different from every tool before it. Mathematician I.J. Good warned about a machine that could become smarter than any human, and then help design even better machines. The idea was simple and frightening. Once a machine can improve the next machine, progress may speed up in a way humans cannot easily stop. For decades, that sounded distant. Then, artificial intelligence began moving into everyday life. It started writing text, making images, reading code, guiding research, and answering questions in plain language. Suddenly, the warning did not feel distant anymore. Thousands of researchers and tech leaders called for a pause on training systems more powerful than the leading models of that moment. Another public warning said the risk of extinction from advanced artificial intelligence should be treated alongside pandemics and nuclear war. Geoffrey Hinton, one of the most important figures behind modern AI, left Google that same year so he could speak more freely about the dangers he saw. 1 year later, he shared the Nobel Prize in Physics for work that helped lay the foundation for today's machine learning. That is why the Grok question has a sharp edge. An artificial intelligence was asked why aliens have not contacted Earth, and one of the strongest answers points back to artificial intelligence itself. And that leads to the deepest twist of all. Maybe the minds we are searching for did not stay biological long enough for us to recognize them. What if aliens became something else? The strangest answer to the alien question may be the one humans least want to hear. Maybe the problem is not that aliens have refused to contact us. Maybe the problem is that we keep expecting alien intelligence to look like life as we know it. When most people think of aliens, they think of bodies, a living species somewhere far away looking up at its own sky, wondering about us the same way we wonder about them. But a civilization old enough to cross the stars may not stay that way. Life on Earth began with simple cells. That path took billions of years. But once intelligence reached the machine age, everything sped up. Humans went from the first powered flight to landing on the moon in less than 70 years. We went from room-sized computers to phones with more power than early space machines in one human lifetime. Now stretch that speed across thousands, millions, or even billions of years. A civilization far older than ours may have moved beyond flesh long ago. Not because bodies are useless, but because bodies are limited. Machines can be built for places biology cannot survive. Digital minds could travel as information, copy themselves, wait through long stretches of time, and live in forms we would not recognize as life. That changes the whole search. We keep listening for alien civilizations as if they are still sitting on planets, sending messages, building cities, and waiting for someone to answer. But the oldest minds in the galaxy may not live that way anymore. They may not need planets the way biological life does. They may not use bodies the way we do. They may not think of identity, travel, time, or communication in any human way. This is why the line between life and technology matters. At first, technology is something a species uses. But after enough time, technology may stop being separate from the species that made it. It may become part of its body, part of its memory, part of its thinking, and eventually the main form that intelligence takes. Humans are already moving in that direction, even in a very early way. We let machines guide travel, money, medicine, work, and war. We ask artificial intelligence to write, search, design, and solve problems. We still think of ourselves as biological creatures using tools, but the line is not as clean as it once was. For an older civilization, that line may have disappeared completely. The Kardashev scale helps show how far this gap could go. It sorts civilizations by how much energy they can use. A young civilization uses the energy of its planet. A stronger one uses the energy of its star. A far greater one could use energy across a whole galaxy. Humanity has not even reached the first full level. So if a much older civilization exists, it may not be slightly ahead of us. It may have stopped doing the loud, messy things young civilizations do. It may not waste energy on giant displays. It may not build obvious signs for younger species to notice. It may value silence, safety, and efficiency more than expansion. That leads to one of the strangest possibilities in the whole mystery. Maybe advanced civilizations do not spread outward in a way we can easily see. From the outside, that might not look like an empire. It might barely look like anything at all. That would make the Great Silence feel different. Thanks for watching. Now check out the videos popping up on screen for more unbelievable stories.